This is Engage New York, Module 2, Lesson 13. Read the objective out loud while I read it. I can use whole number multiplication to express equivalent measurements. So we're going to go ahead and start with our fluency. We're going to multiply by 0.1, 0.01, and 0.001 here. Do you notice a pattern? What is the pattern? Let's write it down. Unit conversions. If you know that 1 foot is how many inches, so you're just going to go through here. And remember, 100 centimeters is equal to how many meters? Show me with your finger. 100 centimeters is equal to how many meters? Yes. So you're going to take that information and go with it. On the back, we have our application problem. So, do you know what? We're going to actually do the application problem together. So, go ahead and just begin with your fluency here, and I will check back and we will debrief in 3 minutes. Go. All right. So, I'm going to move my decimal twice. Remember, our decimal really does live right here, and because this is tenths, it's also 1/10. Decimals are fractions, and fractions are really division. So we're going to move it. There are 2 numbers behind the decimal. I'm going to move it once, twice. The number is 3. My decimal is really there. I'm going to move it 1, 2, 3. There are 3 numbers behind the decimal. My answer is 3. There are 3 numbers behind the decimal. 1, 2, 3. My answer is 5. There's 1 number behind the decimal. My answer is 5. My product. There are 2 numbers behind my decimal. Product is 5. 1, 2, and product is 50. 1, 2, 30. 3. 1, 2, 3, 30. 1, 2, 3, 50. You guys catching on now? All right. So up here, I'm going to move it once, 40. Once, 400. Once, and I'm going to have 4,000. I'm going to move it once, it's 4. Twice, 7. Twice, 70. Twice, and I end up with 700. 1, 2, 7,000. And finally, 1, 2, 3. 1, 2, 3, 7,000. Yes? You guys got it now?
Yeah.
Okay. But if it was 10, 100, and 1,000, your decimal would be moving in this direction. But because this is a decimal, and decimal is a fraction, and a fraction is really division, it's going the other way. Okay? All right. What pattern do you notice? Okay. Say it again, Oliver.
So, all the numbers are equal the same thing when you do the work on the first side, but they just get 1 more 0 each time.
Okay.
And on the decimal side, it goes the 0.0.01 and then 0.01 again, and then it does it twice in a row.
Oh, okay. So picking up patterns and being able to explain patterns is really a big idea. Yes, Jose?
I think I noticed pattern.
Yeah?
I see in the second row, I see like in the first 3, the zero went up by 1. You added 1 more 0. And the same thing happened when you were going 7.
Mm-hmm.
But it got stuck at 7,000.
Okay. Well, I'm gonna write. All right. Okay. Turning to our application problem. All right. So I'm not gonna pass out a string to you. We just made, because this would have been a lot of work to make all of you guys this stuff. So Okay, so we have a 9 centimeter piece of paper, a 20 centimeter piece of paper, a 75 centimeter piece of paper, and 105 centimeter paper. Okay, so we have, okay, I'm going to start recording again. No, I was on pause. I'm going to record right now. No, I'm not.
They're recording.
Okay. So we have 4 pieces of paper, not string. And we have a 9 centimeter, 20 centimeter, 75 centimeter, and 105 centimeter. So we have A, B, C, and D. So let's start off with 9 centimeters. Okay. Then we have 20 centimeters. Then we have 75 centimeters. Then we have 105 centimeters. So we're going to go ahead and start with those. Now, we are going to convert. We're going to convert to meters, and we're going to convert to millimeters. So it's just like we have them. We have paper. We're going to express these in meters, centimeters, and millimeters, and we're going to share out. So since we're not allowed to actually share things right now, we're just going to go through, and our big idea is going to be to convert from going from centimeters to meters and centimeters to millimeters. So we're going to go, here is our we're going to convert, friends, from centimeters to meters, and then centimeters to millimeters. Now, let's draw a little place value chart right underneath here. So, if here is our decimal, and here are meters, remember we have decimeters here, and we have centimeters here, and millimeters here, right? Do you remember us making a chart like this before?
Yeah.
Yes? Yeah. Oh, all right. I'm going to give you a hint, and then I want you to see if you can take my idea and go with it. So if I have 9 centimeters, I'm going to end up, my number is going to get much smaller when it comes all the way over to meters. So my answer product becomes 0.09. How'd you guys do on that? Now, if we have 20 centimeters, 20 centimeters, 20 centimeters, now I have to convert just like I did here. So I'm going from centimeters all the way over to meters. What do you think? Okay, so notice the pattern. The number gets smaller as it moves to the meters, and it's actually getting bigger as it's going to the millimeters. All right. It's going to take a whole lot of millimeters to equal that meter. All right. Now we have 75 centimeters. We're going to move our decimal twice and become 0.75 meters. And then my 750 centimeters becomes 750 millimeters. Yes. Now my centimeters, I have to move my decimal twice. I'm going to move my decimal twice because I'm moving it over. And this becomes 1.05 meters. And then I'm going to have, what am I going to have over here for millimeters? Thank you very much. Yes, that is correct. Okay, so I think about this idea as we're going through the whole idea of converting. We're going to start kind of easy on our converting, but we're going to use whole number multiplication to express equivalent measurements. So equivalent. So that's what we're saying. This is equal to this is equal to this. Like we have to just move our decimals back and forth. All right. That ends our fluency practice for right now, and we're going to start concept development.